Right now, the sun is doing something it's been doing for about 4.5 billion years. Burning. Fusing hydrogen into helium at a rate so violent, it releases more energy in 1 second than humanity has ever used in its entire recorded history. And you don't think about it. You wake up, the light's there, the warmth is there, your coffee is hot because energy from a nuclear furnace 93 million miles away made it through the atmosphere and heated the planet just enough to make your morning feel normal. The whole thing is so reliable, so constant, that it basically doesn't exist to you. It's furniture. Background. So here's the question nobody really wants to sit with. What happens the moment it stops? The first thing to understand is that you wouldn't know. Not right away. Light travels at about 186,000 miles per second, and the sun is roughly 93 million miles from Earth, which means the light you're seeing right now actually left the sun about 8 minutes and 20 seconds ago. So if the sun vanished at this exact moment, you'd have 8 full minutes of not knowing. You'd be standing outside in what feels like a normal afternoon. Birds still flying, traffic still moving, everything completely fine. And then the light just stops. 1 second it's there, the next second it isn't. No warning, no flicker, just darkness, absolute and total, in the middle of the day. And the moon goes with it. That's the part people don't think about. The moon doesn't make its own light. It reflects the sun's. So the moment the sun disappears, the moon disappears too. You'd still have stars. Distant ones, ancient light that left those sources thousands of years ago, arriving right on schedule regardless. But everything close, everything familiar gone. No moon to navigate by at night, no glow through the curtains, nothing. The sky you've looked at your whole life would be unrecognizable, and you'd be standing in a darkness that no human alive has ever actually experienced. The immediate effects would extend beyond darkness into the physical structure of the atmosphere itself. Without the sun's radiation, the upper atmosphere would begin cooling at a rate of several degrees per hour. The thermosphere, which is normally heated by solar ultraviolet radiation to temperatures exceeding 1,000 degrees Fahrenheit, would collapse into itself. The mesosphere would follow. These layers exist only because of solar heating. Remove that heat source, and they cease to exist in any meaningful way. The stratosphere would cool much more slowly, but the trend would be unmistakable. The entire vertical structure of the atmosphere would begin reorganizing itself into a new, colder equilibrium that has no precedent in Earth's recent history. Now here's where physics gets involved in a way that's almost hard to believe. Einstein showed that gravity travels at the speed of light. Same speed. Same 8-minute delay. Which means for those first 8 minutes, Earth isn't just losing light from the sun. It's still being held in orbit by gravity from a star that no longer exists. And then that stops too. At the exact same moment the darkness hits, Earth's gravitational tether to the sun snaps. The planet, which has been traveling at roughly 67,000 miles per hour in its orbit, suddenly has nothing pulling it into a curve anymore. So it does what any object does when the force holding it in a circle disappears. It goes straight. Earth just starts moving in a straight line into open space at 67,000 miles per hour, carrying everything on it along for the ride. The temperature collapse starts almost immediately, but it doesn't feel catastrophic at first. That's what makes it insidious. The first day, global average surface temperatures drop by roughly 20 degrees Fahrenheit. That's uncomfortable, alarming, but survivable. People in warmer climates barely notice. In temperate zones, people reach for a jacket and assume it's a weird weather event. The oceans are still releasing heat they've been absorbing for centuries. The atmosphere still holds some residual warmth, and there's enough thermal inertia in the planet that the first few hours feel more like an unusually cold night than the end of everything. Within a week, average surface temperatures fall below freezing everywhere on Earth. Everywhere. The tropics, the equatorial belt, the regions that have never seen frost in recorded history. It all goes below 0 Celsius within 7 days. Most small plants are already dying by this point, the frost killing them before the darkness fully does. Crops fail across every continent simultaneously. The food system, which operates on almost no spare margin under normal conditions, starts showing cracks within days. Grocery stores in most countries carry about 3 days of inventory. That becomes relevant very quickly. Supply chains, which depend on refrigeration, transportation, and the basic assumption that tomorrow will be similar to today begin fragmenting within hours. Trucks stop running. Ports freeze. The mechanical systems that move calories from farms to cities seize up as temperatures plummet and fuel becomes precious. Within weeks, there is no coordinated global food system at all, only regional, then local, then personal struggles for calories. Photosynthesis stops almost the moment the sunlight does. This matters more than almost anything else about the scenario, because photosynthesis isn't just how plants make food. It's the engine that runs the entire biological economy of the planet. Every herbivore on Earth is eating stored solar energy when it eats a herbivore. The entire food web, every trophic level from insects to blue whales, is downstream of photosynthesis, and it stops immediately. Smaller plants die within days to weeks. Larger trees, ones with enormous reserves of stored sugar and very slow metabolisms, can actually hold on for several decades, burning through their stores in near total darkness. But the base of the food chain collapses fast. Herbivores starve first, then the animals that eat herbivores. Then everything else cascades downward in a sequence that's brutal in its logic. Scavengers and decomposers persist longer, feeding on the bodies of organisms that die around them. But even that food source is finite. The insects, which depend almost entirely on plant material or on animals that eat plants, essentially vanish within a few months. Most insect species would be extinct within a year. The loss of insects alone triggers secondary collapses in the food web. Birds that depend on insects for food have no source of nutrition. Amphibians, which have complex life cycles that depend on seasonal cues and insect abundance, face near total extinction. The whole interconnected system of interdependencies that makes an ecosystem function simply breaks apart. There are ecosystems at the bottom of the ocean, clustered around hydrothermal vents that have never used sunlight at all. Tube worms, shrimp, microbial mats. They run entirely on chemical energy from Earth's interior, completely independent from the sun. Those communities would carry on largely unaffected for a very long time. Everything else, every ecosystem that touches sunlight even indirectly, starts dying within weeks. Now, one thing that surprises most people: you wouldn't suffocate. Not right away. Not even close to right away. The atmosphere holds roughly 1,000 years' worth of breathable oxygen even without plants continuously replenishing it. Cold, starvation, and darkness would kill most surface life long before the oxygen became an issue. The atmosphere itself doesn't freeze immediately either. It takes time. Months before the oceans start icing over at the surface. Centuries before the deep ocean freezes. And all the while, Earth is drifting further and further from its original orbit, moving through a region of space it was never supposed to occupy. The deep ocean is actually remarkable in this scenario. Surface ice forms an insulating layer that dramatically slows the heat loss below it. And the deep ocean, which is already only a few degrees above freezing under normal conditions, retains liquid water for an extraordinarily long time. Some models suggest hundreds of thousands of years before the seas freeze solid all the way down. And Earth's interior keeps generating heat through the slow radioactive decay of elements in the mantle. That heat seeps upward, not enough to warm the surface in any meaningful way, but enough to keep liquid water near those hydrothermal vents, enough to keep some things alive in the dark for an almost incomprehensible stretch of time. The atmosphere eventually collapses entirely. Carbon dioxide starts freezing out of the air at around -109 degrees Fahrenheit, falling as dry ice onto the surface. Then other gases follow. The whole gaseous envelope that has protected life on this planet for billions of years, that has deflected radiation, moderated temperature, carried weather, made breath possible, essentially crystallizes and settles onto the surface. Cosmic radiation that the atmosphere used to block starts reaching the ground directly. At that point, the surface of Earth is functionally indistinguishable from the surface of a dead rock drifting through open space. Physicists at Caltech have estimated that Earth's final stable temperature, the point at which heat leaking out of the core balances the heat radiating into space, would settle around -400 degrees Fahrenheit, which is almost exactly the surface temperature of Pluto. The planet that was once the third rock from a star, the one that hosted oceans and forests and cities and billions of years of evolving complexity, would end up essentially identical to a frozen dwarf world at the edge of the solar system. The transformation would take millions of years to complete, but the direction would be set within hours of the sun going out. The strangest part of the whole scenario is the 8 minutes. That grace period where everything still looks fine, where the light is still coming in, and the birds are still singing, and nothing has announced itself as wrong yet. 8 minutes of a world that's already over, still running on leftover light. There's something in that which is hard to shake. The idea that catastrophe can be absolute and invisible at the same time. That the thing that ends everything can be completely finished before the news of it even arrives. Human civilization, for all its fragility, would actually attempt to survive. Underground geothermal facilities, nuclear reactors providing heat and electricity, hydroponic farms lit by artificial light, growing food in tunnels and bunkers. The plants would need the electricity would need fuel, the fuel would need supply chains, the supply chains would need people, and all of it would be racing against the temperature drop and the food collapse, and the sheer psychological weight of a sky that never lights up again. Some researchers have suggested that with enough preparation, a small population near geothermal hotspots, places like Iceland or Yellowstone, could survive for centuries, using Earth's internal heat. Small communities, isolated, running on borrowed time from the planet's radioactive core. But here's what none of those survival scenarios can really account for: the sky. Every civilization that has ever existed has been organized, at least in part, around the sun. Religion, agriculture, navigation, the calendar, the entire psychological architecture of the human day. Darkness at night means sleep. Light in the morning means wake. The circadian rhythm built into every cell of your body has been calibrated for a cycle that no longer exists. Without the sun, you don't just lose warmth and food and gravity. You lose the thing that has told every living creature on this planet what time it is for 4 billion years. What happens to a species that evolved under a star when the star disappears is a question that biology has never had to answer before. And if the sun went out tomorrow, we'd be finding out in real time.